Archimedes' principle states that a body immersed in a fluid is buoyed up by a force equal to the weight of the displaced fluid. Essentially, the buoyant force is equal to the weight of the displaced water. If the weight of the water displaced is less than the weight of the object will sink. Otherwise, the object will float, with the weight of the water displaced equal to the weight of the object. In calculating the buoyant force on a body, however, one must also take into account the shape and position of the body. A steel rowboat placed on end into the water will sink because the density of steel is much greater than that of water. However, in its normal keel-down position, the effective volume of the boat includes all the air outside it. In calculating the buoyant force on a body, however, one must also take into account the shape and position of the body. A steel rowboat placed on end in the water will sink because the density of steel is much greater than that of water. However, in its normal keel-down position, the effective volume of the boat includes all of the air inside of it, so that its average density is less than that of water, and as a result, it will float. Think of the buoyancy of steel ships. What makes this design float and this design sink? The reason is simple if you put it into terms of Archimedes' principle. For the ball design, the displaced water weighs less than the ball, whereas with the hull design, the displaced water equals the hull weight. This principle applies to both floating and submerged bodies, and to all fluids including liquids and gases. It explains not only the buoyancy of ships and other vessels in water, but also the rise of a balloon in the air and the apparent loss of weight of objects underwater. To determine whether a given body will float in a given fluid, both weight and volume must be considered. That is, the relative density, or weight per unit of volume, of the body compared to the fluid determines the buoyant force. If the body is less dense than the fluid, it will float, or in the case of a balloon, it will rise. If the body is denser than the fluid, it will sink. A few applications of Archimedes' principle are submarines, hot air balloons, and ships.